Imagine for a moment, just for a moment, and the silence outside, the quietness of the night breathing softly like the deep sea, the air in your room still, a little colder now. Feel the weight of your body, the gentle gravity, this invisible anchor holding you, connecting you to the center of everything. Feel the contact of your skin with the sheets, the texture, the temperature. You are here, you are present, and you are awake. Perhaps your mind today feels racing. A whirlwind of thoughts, echoes of the day, worries of tomorrow, small sparks of electricity running faster than light, seeking a place to land, seeking meaning, seeking an answer. Your racing mind is not your enemy. It is not a glitch in the system. It is just the energy that has forgotten for a moment the vastness from which it is made. It has forgotten the deep silence that sustains it. Tonight, we are not going to fight these thoughts. We are just going to change the scale, change the perspective. Let's use silence itself as a vehicle. What you may not know as you rest there is that you are, at this very moment, floating. You are falling, but it is not a fall. It is a drift. You are adrift in what astronomers call a great void. It is not a metaphor, it is not philosophy. It is your cosmic location. Imagine a desert, not of sand but of space, a desert so vast. That light, at its relentless speed of 300,000 kilometers per second, would take 2 billion years to cross it from one end to the other. 2 billion years. Think about what that is. The light we see today, from the edge of this void, left long before complex life forms existed on Earth, before the first trees as we know them existed, a light that traveled since before human memory, since before humanity itself, just to cross the desert we live in. Our galaxy, the Milky Way, with its billions of stars, the Sun, the Earth, you, is just a grain of luminous dust in this immense desert. Scientists call it the KBC void, a place where matter, galaxies, nebulas, stardust, is 20% more rarefied than in the rest of the universe. 20%. We are in a bubble of almost nothing, a region of deep, deep cosmic quietude, a place where the universe literally breathes slower. Think about it. When astronomers look out from here, from inside this void, the universe seems to be expanding faster than it should. Our most fundamental equations, our rulers for measuring the cosmos, seem distorted. What if the problem isn't in the stars, but in our perspective? What if the place where we are, this deep cosmic desert, is actually distorting our perception of reality? The human mind does the same. When we are immersed in our own anxiety, in our own inner void, the world outside seems faster, more threatening. Problems seem to expand uncontrollably, a kind of Hubble tension of the soul. But perhaps it is just perspective. Perhaps we are just measuring the world from inside a deep valley, forgetting that mountains exist. The scientists who discovered this void, Ryan Keenan, Amy Barger, Lennox Cowie, in 2013, didn't do so looking for nothingness. They were doing something methodical. They were counting galaxies, 35,000 of them, mapping the visible universe point by point of light, and suddenly they realized the numbers were wrong. Imagine the feeling, looking at the data, the three-dimensional maps of the cosmos, and seeing a hole. Where there should be thousands of points of light, there were fewer. Where there should be light, there was deep silence. Not just a little less, 20% less. In all directions, a sphere of quietness, stretching for 1 billion light years, and we are near the center. This is not a small space between clusters. It is a feature on a scale that, according to standard cosmology, should barely exist. Computer simulations. The stories we tell ourselves about how the universe evolved rarely produce voids so large and so empty. It is so statistically unlikely that some say we shouldn't find a single void like this in the entire observable universe, a deviation so extreme from the average that it borders on impossible. And yet, here we are, living inside it. The researchers checked their data 3 times. They used multiple galaxy surveys, looked at the sky from different angles, trying to find the error. But the result remained consistent. Our galaxy, our home, and everything around it is situated inside a bubble of underdense space. Gigantic. A bubble that overshadows everything we have ever observed. They gave it a casual name, the KBC void, the initials of its discoverers. But there is nothing casual about what it represents. In the standard model of cosmology, the story we accept, the universe should be uniform, homogeneous, when we look at sufficiently large scales. Of course, galaxies cluster, like foam on the ocean. They leave empty spaces between them. That is expected. But a region so huge, with such a significant deficit of matter, pushes the limits of what chance can explain. Some scientists calculated that a 10 sigma deviation from the average density would be needed, a statistical term to say, so unlikely it shouldn't happen. And yet, here we are. The implications of this discovery began to accumulate immediately, like silent snow. If we reside in such an unusual location, does this influence all our measurements? When we point our telescopes at distant supernovas, the cosmic candles we use to measure the expansion of the universe, are we witnessing the true cosmic rate, or are we seeing a local, distorted version? The void hypothesis, this desert, offered an answer to one of the greatest mysteries of modern cosmology, the Hubble tension. For years, scientists measured two different expansion rates. One looking at the ancient universe, the light from the Big Bang. Another looking at the nearby universe, the stars around us. And the numbers don't match. They diverge by 9%. It seems small. But in physics, it represents a crisis. Both measurements are incredibly precise. Both should give the same answer, but they don't. What if Earth is inside this under-dense region? The gravity of matter, the denser matter that is outside the void, at the distant edges, would pull the galaxies inside it outwards. Imagine the void as an immense valley, almost flat, and around it, the dense matter of the universe forms mountains. The gravity of those distant mountains gently pulls everything in the valley, not inwards but outwards. We are not falling into a hole, we are being gently pulled into the vastness. This would add extra speed to the movement of nearby galaxies. It would make the local expansion seem faster than the average. Suddenly the conflicting measurements, the crisis, made sense. We are not measuring the universe incorrectly. We are measuring it from a distorted perspective. We are measuring from inside a hole. This realization changed everything, but it also raised an uncomfortable question, one that cosmologists are still trying to understand in the silence of the night. If our location is so unusual, can we trust anything we think we know about the cosmos? And what exactly fills this desert? Cosmic voids are not truly empty, and that makes them even stranger than the name suggests. Between these lonely galaxies, like ours, stretches a space. A space that breathes with the presence of dark matter, a space filled by the constant pressure of dark energy, and occasionally a trace, a whisper, of primordial hydrogen gas, the echo of the first moment. The density here is so unimaginably low that gravity, the great sculptor of the universe, barely works. Think about it. Gravity is the force that builds worlds, that ignites stars, that gathers galaxies in majestic dances. But here, in this void, it has little clay to work with. Without enough mass to bind things together, the formation of new structures ceases. No new galaxy cluster can be born. No new nebula can light up. The void remains void. And in this realm of scarcity, gravity, the force that anchors us to the ground, becomes almost irrelevant. The dominant force becomes another, dark energy, the mysterious pressure that accelerates the expansion of the cosmos, the breath of the vacuum, a force that does not pull, but pushes. In dense regions like galaxy filaments, gravity fights against dark energy. The attraction of matter is strong, and it breaks the expansion, holding structures together. But here, inside the voids, gravity loses the contest. Dark energy wins, decisively. As a result, voids expand faster than the rest of the universe. They grow like bubbles of silence, pushing the walls of galaxies away, further and further. It is a self-reinforcing cycle, a mantra of stillness. The more the void expands, the emptier it becomes. And the emptier it becomes, the faster it expands. Think of the KBC void not as a place, but as a process, a state of being, a rhythm of expansion. Scientists confirmed this through careful observation. They measured how galaxies near the edges of voids move, compared to galaxies in denser regions. The void galaxies, are moving away from the center faster than cosmic expansion alone would explain. Something is pushing them out. That something is the gravitational pull of all the matter outside the void. Think again of the void as a valley surrounded by mountains. Gravity pulls you towards the mountains, not towards the center of the valley. But since we are talking about space and not terrain, this gravitational force causes galaxies to expand outwards. The effect is measurable. It is significant. Our own galaxy, the Milky Way, is moving away from the center of the local void at more than 900,000 kilometers per hour. Propelled by this gravitational imbalance, the interior of a void becomes a strange place for physics. Light traveling through it experiences less gravitational influence than light traversing normal space. This affects our observations in subtle ways. When astronomers study the cosmic microwave background radiation, that faint residual glow of the Big Bang, the first light, they notice that light passing through voids seemed slightly colder. Reduced gravity in voids causes an effect, a signature, manifesting as cold spots on the temperature maps of the early universe. And these cold spots align perfectly with the locations where we observe large voids today. It is not a coincidence. It is physics. It is the void leaving its fingerprint on the oldest light in existence. Understanding what makes voids empty helps us understand why they are so important. They are not just boring spaces between the interesting parts of the universe. They are laboratories. Laboratories where dark energy dominates and gravity takes a secondary role. Studying how matter behaves differently here, in silence, versus out there in the noisy filaments, scientists can test fundamental theories about how the universe works. The KBC void around us might be unsettling. It makes us question our normality, but it also offers a rare opportunity. We are positioned exactly in the right place to study the most serene, darkest, and strangest environments in the universe. The structure containing these voids is much stranger than anyone imagined. Imagine for a moment that you could step back far beyond your room, far beyond Earth, beyond the sun, beyond the Milky Way. If you could step back so far that galaxies became just shimmering grains of sand, what would you see? You wouldn't see a uniform soup. You wouldn't see a homogeneous mist. You would see foam. Scientists call it the cosmic web, nature's largest structure. Imagine a three-dimensional net of light, thin, delicate threads made of thousands of galaxies stretching through the darkness, filaments intersecting, weaving together like the neurons of a titanic brain, or like the veins of an invisible leaf. At these intersections, where filaments meet, matter clusters. That is where gravity sings loudest. That is where great galaxy clusters shine, buzzing with activity, with heat, with violent mergers. But between these filaments, between these walls of light, are the bubbles, the voids. They occupy most of the volume, 90%. Think about that. 90% of the universe is the silence between the notes. It is the space between the strings of the web. We do not live in a universe teeming with galaxies. That is an illusion created by our proximity to light. The truth, the vast and cold truth, is that we live in a cosmos of void, punctuated here and there by rare islands of matter. And the KBC void, where you are now, is one of these immense bubbles of silence. But the story gets deeper and more paradoxical, because even within this desert, we are not alone. The Milky Way belongs to a family, the local group, and the local group belongs to something even bigger, a river of galaxies. In 2014, astronomers mapped the movement of 100,000 galaxies around us. They didn't just look at where they were, but where they were flowing. They discovered that our galaxy and all our neighbors are sliding together through space, like drops of water in an immense watershed. We are flowing toward a deep gravitational valley. They gave a name to this colossal structure, a name that sounds like an ancient prayer, Laniakea. In Hawaiian, it means immense heaven or immeasurable paradise. Laniakea is 500 million light-years across. It contains the mass of 100 quadrillion suns. It is our supercluster. It is our continent in the ocean of space. But here is the mystery that keeps cosmologists up at night. Laniakea, with all its grandeur, with its 100,000 galaxies, resides entirely inside the KBC void. How is that possible? How can one of the largest structures we know be inside a hole? It is a question of scale and a question of perspective. For us, small biological beings, Laniakea is everything. It is our horizon. But for the KBC void, Laniakea is just a thread of dust. The void is so vast, so incomprehensibly big, that it can swallow entire superclusters and still have room to spare. Laniakea is just one of the rare concentrations of matter, a small island of noise, floating in the vast arid expanse of the void. Think of your own life, your problems, your joys, your history. They are your Laniakea, a supercluster of experiences, dense, rich, complex. But all of this happens within a larger context, within the mystery of existence, within time, within silence. The void does not annul Laniakea. It contains it. Your anxiety does not annul who you are. It is just the space where your thoughts float. But where did this void come from? How did the universe decide that here, exactly here where we are, there would be less matter? The answer takes us back to the beginning of everything, to the first breath of the cosmos. Immediately after the Big Bang, that long before stars or atoms or even light as we know it existed, the universe was a sea of energy, almost perfectly smooth, almost perfectly uniform. But almost is the word that allowed you to exist. There were fluctuations, quantum fluctuations. Imagine the surface of a calm lake. Now imagine that, for no apparent reason, tiny ripples appear. Tiny, imperceptible. Those were the seeds. In some regions, by pure chance, the density was slightly higher. 1 part in 100,000, just a fraction more energy. In other regions, the density was slightly lower. Gravity, patient and relentless, began to work. The denser regions had more gravity. They attracted the matter around them. They stole energy from their neighbors. They grew. They became the filaments. They became Laniakea. They became us. But the less dense regions, the regions that started with a tiny deficit, lost. They lost their matter to voracious neighbors. They emptied out. As the universe expanded, these small flaws, these small minuses, were stretched, magnified, over billions of years. The small ripples of almost nothing transformed into the abysses we see today. They became the voids, the KBC void. This desert of 2 billion light-years where you sleep tonight began as a quantum accident, a random fluctuation in the fabric of reality less than a second after time began. The architecture of the universe was not drawn, it was blown, and we are here, in this pocket of silence, only because chance willed it so. There is no reason for us to be in the void instead of a dense filament. It is an accident of cosmic address, but this accident defines what we see and defines what we feel. Now think about the immensity of time. Gravity worked for 13.8 billion years to dig this hole, to drain matter to the edges, and we are in our galaxy, the Milky Way, are participating in this drainage. We are in motion. Remember the speed, 965,000 kilometers per hour. We are being pulled away from the center of the void, toward the nearest mass concentration, the Virgo cluster, and beyond it, the Great Attractor. But there is something even stranger happening at the edges of our perception, something about how light behaves when it crosses nothingness. When astronomers look at the cosmic background radiation, that fossil light, they see patterns, hot spots and cold spots. The KBC void is so big that it should leave a mark on this light. Imagine light as a traveler. When it enters a void, does it have to climb a gravitational hill to get out the other side? Not exactly. In the void, there is less gravity, so it's like walking on flat terrain. But when light exits the void and enters dense walls of galaxies, it falls into a gravity well. It gains energy, but the universe is expanding. While light crosses the void grows. The path stretches. This creates a subtle effect. The light loses energy. It gets tired. It gets colder. Scientists call this the integrated Sachs-Wolf effect, a complicated name for something poetic. The void steals heat from light, and that is what we see. A coldness, a temperature signature confirming we are surrounded by emptiness. But if we are in such a special place and so vast and so empty, doesn't that change the rules of the game? This brings us back to that tension, that disagreement between measurements. If we live in a bubble that expands faster, and if that bubble is so big it swallows our horizon, then perhaps our entire cosmology needs a footnote, a note that says, measured from inside the void. Perhaps the universe is not as young as it seems from here. Perhaps it is not expanding so frantically everywhere. Perhaps it is just our peculiar velocity, our local anxiety projected onto the stars. And that brings a strange peace, doesn't it? The idea that the urgency we see, the speed at which things seem to move away, might just be an optical illusion caused by our position. Out there, beyond the mountains of galaxies surrounding our void, the universe might be calmer, slower, older. Perhaps time is in no rush, and you don't need to be either. If you like exploring these silent corridors of space and mind, if you want to continue unraveling the secrets the cosmos keeps in the dark, subscribe to the channel, leave your like, become part of this crew navigating the void. Let's continue our drift. There is still more to see, and as you float deeper into this silent current, the very definitions of time begin to unravel. The existence of the void, the existence of this bubble where we live, threatens one of the oldest certainties we have. It threatens the age of the universe. Think of your own age, the number of years you carry. It is a fixed number, a count of laps around the sun. But for the cosmos, age is a deduction. It is a story told backward. Current measurements, those based on ancient light on background radiation, tell us the universe is 13.8 billion years old. That is the time passed since the first breath, since the Big Bang. But, and here the silence becomes unsettling. If the local expansion rate measured here from inside our void is the true global rate, if the universe is really expanding as fast as it seems from in here, then our math is wrong. If the universe expands faster, it reached its current size sooner. It ran. It was in a hurry. This would mean the universe is younger. Calculations show that if our local view is right, the universe might be only 12.7 billion years old. A billion years lost, gone. This might seem like just a numerical adjustment, but it creates an impossible paradox, a ghost in the machine of reality. Because we observe stars, we look at globular clusters, those spherical cities of ancient stars, floating like ghosts in the outskirts of galaxies. And when we measure the age of these stars, based on how they burn their fuel, on how they live and die, they seem to be 13 billion years old. Some seem to be even older. And here is the problem that doesn't let astrophysicists sleep, but might help you rest. You cannot have stars older than the universe itself. You cannot have a daughter older than the mother. You cannot have a thought that existed before the mind that thought it. It is a logical impossibility. But the numbers insist. The stars tell us they are ancients. The universe, seen from our void, tells us it is young. Who is lying? Either our measurements of star ages are wrong, and our understanding of how suns work is flawed, or the rapid expansion rate does not apply to the universe as a whole. Neither option is comfortable for science. Science likes order, likes clean timelines. But the void doesn't care about our comfort. The void hypothesis offers the only reconciliation, the only peace. It suggests that the youth of the universe is an illusion created by our bubble. Expansion seems fast here because the void pushes us, because the gravity of distant mountains pulls us. But out there, beyond the bubble, the universe is ancient. It is its 13.8 billion years. It is old enough to have given birth to those ancestral stars. The tension, the paradox, dissolves when we accept that our vision is limited. Perhaps your own sense of time is like this. Sometimes days seem to race. Anxiety makes the clock spin too fast. You feel you don't have enough time, that you are late. But that is just local expansion. That is just the void of haste pushing you. Out there, in the greater reality, time is vast. Time is sufficient. You are not late. You are just in a region of high peculiar velocity. And how do we measure these things? How do we know the size of this dark room we are in? We use a ruler, but not a wooden or metal ruler. A ruler made of sound. Astronomers call it baryon acoustic oscillations, a technical name for something deeply poetic. The echo of the universe's first song. In the first 380,000 years, when the universe was a hot, dense plasma, bright as the interior of a star. It was not silent. There were pressure waves, sound waves. Traveling through the primordial fire, when the universe cooled, when the first atoms formed and light broke free, those sound waves froze. They stopped. Imagine a lake where you throw a stone. The ripples spread. Now imagine the water freezes instantly. The ripples get trapped in the ice. That is what happened. The sound waves of the Big Bang got frozen in the distribution of matter. The distance these waves traveled before freezing, about 490 million light years, became a standard ruler, a fixed measure printed on the sky. We can look for this ruler in the distribution of galaxies. We can see if galaxies tend to cluster separated by this specific distance. And when we use this sound ruler, this frozen memory of a primordial sound, to measure our void, what do we find? We find discrepancies. We find that in here, the ruler seems to be the wrong size. Measurements confirm we are in a region where matter behaved differently, where sound traveled differently. We live in an out-of-tune note, or perhaps in a pause in the symphony. And it's not just sound, it's temperature. Remember the cold spot. On the cosmic background radiation map, there is a smudge, a region in the southern hemisphere of the sky, in the direction of the constellation Eridanus. It is a huge smudge, and it is inexplicably cold, much colder than random fluctuations should allow. It is like a scar on the face of the baby universe. For years, this was a mystery. Some spoke of colliding universes, others of instrument errors, but now the most likely explanation is another void, the Eridanus supervoid, a cousin of our KBC void, perhaps even bigger, an abyss almost 2 billion light-years across, located 3 billion light-years away from us. The light that traveled through it lost energy, tired itself climbing the mountain of accelerated expansion, and arrived here, cold. We are not alone in our loneliness. The universe is full of these abysses. The KBC void, the Eridanus supervoid, are like islands of silence in a vast archipelago. If we looked from there, from that other void, maybe we would see the Milky Way as a cold spot in their sky. Maybe there are civilizations there, floating in the darkness of Eridanus, looking at the empty sky, wondering why the universe seems so lonely. Perhaps they also feel time runs too fast. Perhaps they are also measuring expansion and finding numbers that don't match. There is a solidarity in distance, a connection between cosmic castaways. This brings us to the concept of the Hubble bubble. It is a term scientists use, half seriously, half uncomfortably. The idea that our measurements are valid only inside our bubble, that we are trapped in an aquarium of biased data. When we measure things nearby, within 2 billion light-years, we are measuring the aquarium water. When we measure things beyond that, we are trying to see the ocean through the glass. The glass distorts, the void distorts. We are, in a way, trapped in our own perspective. It is like trying to determine the average temperature of the Earth without ever leaving a heated room. You may have precise thermometers, you may be a brilliant scientist, but if you don't know you are in a heated room, your conclusion about the world will be wrong. You will say, the world is hot. We say the universe is expanding at 73 kilometers per second, but perhaps, out there in the cold, it is expanding at 67. Accepting the Hubble bubble, accepting the KBC void, is an act of humility. It is admitting we are not the neutral observer. We are not the God's eye seeing everything from outside. We are part of the landscape. We are affected by the terrain. Our anxiety, our haste, our sense of isolation are not defects. They are data. They are information about where we are. Do you feel the weight of the world? Perhaps it is just the gravity of dense matter out there pulling you. Do you feel like you are running without moving? Perhaps it is the expansion of the void, stretching the ground beneath your feet. But there is beauty in this. If the ancient stars, those 13 billion years old, really exist, and they do, they are the guardians of truth. They shine with a light that ignores our wrong measurements. They know their true age. They have no identity crisis. They are the anchor. Even if our maps are wrong, the territory is real. The stars are there. Time has passed. History happened. You don't need to understand the math of expansion to be part of it. You don't need to solve the Hubble tension to have the right to exist. You are already here, inside the bubble, inside the void, safe. And the future? What does the future hold for a place like this, as dark energy continues its silent work? Pushing, stretching, expanding, isolation will increase. The filaments we see in the distance, the walls of our cosmic cave, will move away. The light from other galaxies will be stretched until it becomes invisible. The cosmic horizon will shrink. Billions of years from now, a civilization born in this void will not see other galaxies. They will not see the background radiation. They will not see proof of the Big Bang. They will see only darkness. And the few stars of their own dying galaxy. They will think they are all that exists. An island universe, static, eternal, alone. We live in a privileged era, a golden age. We can still see the walls. We can still see the neighbors. We can still see the glow of the beginning. We know we are in the void because we can still see what is not void. Your anxiety, your awareness of vastness, is a privilege. It is proof that you can still see beyond the walls. You are not trapped in darkness. You are at a lookout, a silent lookout, 2 billion light years wide, built just for you to observe eternity. Breathe. Let this scale enter your lungs. You are made of atoms forged in stars that now seem to be moving away. You are the memory of the universe. And memory does not need to rush, but stillness is an illusion. Even here, in this silent lookout, nothing is truly still. The stability you feel now, the firm ground beneath your feet, the motionless house, is just a matter of reference frame. In truth, we are running. Our galaxy is not just floating passively, it is being pushed. It is sliding out of the void with a silent urgency that defies imagination. Imagine a dry leaf fallen on the surface of a vast, smooth lake. If you touch the water in the center, the ripple pushes the leaf to the shore. We are that leaf. Astronomers call our immediate neighborhood the local sheet. A flattened structure, a raft of galaxies including the Milky Way, Andromeda and other smaller companions. And this raft is sailing. We are moving at 965,000 kilometers per hour relative to the center of the void. Think about that number. Almost 1 million kilometers every hour. While you breathe, while your chest rises and falls, you have traveled thousands of kilometers through the darkness, without feeling any wind, without hearing any sound. This speed does not come from the expansion of space. It is a peculiar velocity. It is our galaxy's own movement, trying to escape loneliness. We are being repelled by the void at our backs and attracted by the great concentrations of matter ahead of us. The great attractor, the Shapley supercluster, the distant mountains call us, and the silent valley pushes us. We live in a cosmic current, and this current is so vast, so ancient, that it shapes the very light that reaches us. When we look at the sky, we see a subtle difference in the universe's temperature. In one direction, where we are going, the sky looks a bit warmer. In the opposite direction, where we came from the heart of the void, it looks a bit colder. Scientists call this the dipole. It is the Doppler effect applied to the light of creation. It is like running in the rain. The drops hit your face harder than your back. The light of the Big Bang hits the front of our galaxy harder. This is physical proof of our escape. We are fleeing from nothingness. But what happens to those who do not flee? What happens to galaxies born and dying in the depths of the void, far from the walls, far from the current? They are the true hermits of the cosmos. Void galaxies are different. They grow in deep, almost absolute isolation. Unlike galaxies in dense clusters, living in bustling cities, colliding, stealing gas from each other, evolving fast, void galaxies live in the countryside. They evolve slowly. They tend to be smaller, dimmer, but there is a melancholic beauty in them. Because they are lonely, they rarely collide. They rarely suffer the violence of galactic mergers. This means they keep their original shape for much longer. They are perfect spirals, undisturbed disks of light spinning gently in the darkness, and they are rich in gas, since there are no neighbors to steal their fuel and no collisions to force that fuel to burn all at once in starbursts. Void galaxies save their energy. They are like time capsules. They retain primordial hydrogen, the raw material of the universe, almost untouched. They form stars at a slow, calm, sustainable pace. while cosmic city galaxies live fast and die young, turning into red, dead spheres of old stars. Void galaxies remain blue. Blue is the color of stellar youth. Blue is the color of hot, new stars. It is a fascinating paradox. The emptiest, oldest, and loneliest place in the universe is also the place where galaxies stay young the longest. Isolation preserves. Perhaps there is a lesson in this for your own mind. Often, we fear loneliness, fear being outside the clusters, outside the frenetic movement of society, outside the noise. We feel that if we are not colliding, interacting, producing, we are stagnant. But look at the void galaxies. Silence didn't kill them. Silence preserved them. They didn't burn all their potential in a rush to be big. They kept their gas. They continue forming new stars, new lights, long after giant galaxies have faded. Being in the void, being in this moment of pause, of withdrawal, might be what allows you to keep your own light lit. It might be what prevents you from burning out. The metallicity of these galaxies also tells us a story. In big galactic cities, stars are born and die fast, exploding in supernovas, filling space with heavy metals: iron, oxygen, silicon, gold. The universe gets polluted with the remains of stellar death, but in the void, metallicity is low. The gas is pure. It is a cleaner environment, closer to the beginning of time. If life arises there, on those lonely worlds, it might be different from ours. Rocky planets might be rarer. The chemistry of life might have to be more creative. But if a civilization is born there, it will have something we are missing: stability. Our neighborhood is chaotic. Supernovas explode. Black holes spit jets of radiation. Neighboring galaxies graze past, distorting orbits. But in the void, a galaxy can sail for billions of years without ever meeting another, without ever being disturbed. A planet there could have an uninterrupted geological history, a biological evolution that never had to deal with external cosmic catastrophes. A piece of ages. Imagine being an astronomer on that planet. You look at the night sky, and it is dark, much darker than ours. There is no milky band of neighboring stars crossing the firmament because your galaxy is small and your neighbors are unimaginably distant. You would see only deep darkness and perhaps very far away, like faint smudges, the walls of the void, the distant filaments where the rest of the universe lives. Would you feel alone, or would you feel safe? Perhaps for them, the idea of a crowded, dense, noisy universe sounds like a nightmare. For them, the void is home. The void is normal. And we are the anomaly. We living on this busy edge, running at 1,000,000 kilometers per hour, colliding and burning. We are the weird ones. Your perspective changes when you realize loneliness is not a defect of space. It is most of it. The universe is essentially a loneliness-making machine. Dark energy works day and night to push things apart, to create more space between atoms, to ensure every island of matter has its own ocean of privacy. We fight against this. Gravity fights against this. We want to join together. We want the other's hand. We want fusion. But the final destination is the void, and perhaps that is not something to fear. If the universe tends towards silence, perhaps silence is the natural state of consciousness. All this noise in your head, all this mental Hubble tension, is just gravity trying to hold on to things that want to leave. Let go. Let expansion happen. Allow thoughts to move away, like galaxies at the edge of the void. Let them gain speed and disappear over the horizon. What remains is not nothingness. What remains is the space where new stars can be born. What remains is pure gas. Potential. You are floating on the local sheet, a safe raft. You are protected by vastness. The mountains of problems that seem so big are 2 billion light-years away. And here, in the center, gravity is too weak to knock you down. Here, you float. If you are enjoying this journey through silence, if this change of scale brings some comfort to your night, remember, this channel is a meeting point for void castaways. Subscribe, leave your like. It is a light signal you send to other sailors. Let's continue. We still need to understand what this colossal structure says about the laws governing reality, because the void challenges not only our perception, it challenges Einstein. It challenges the very idea that the laws of physics are the same everywhere. Here is block 5. We dive now into the fundamental laws governing this silence. Let's question if gravity, the most familiar force of all, behaves the same way when no one is looking. The existence of this void is more than a geographical curiosity. It is a challenge. It is a pebble in the shoe of modern physics. For a century, we relied on a set of rules, the rules written by Albert Einstein, general relativity. It tells us how matter curves space, how space tells matter how to move. It is an elegant dance, tested and proven 1,000 times, from the fall of an apple to the dance of black holes colliding in the dark. But the KBC void, this abyss where you sleep, it does not obey these rules well. According to simulations based on Einstein's physics, a void of this size, with this depth, is statistically impossible. It is like flipping a coin 1,000,000 times and getting heads every time. Theory says we shouldn't be here, that this hole shouldn't exist, so we have a choice. Either we accept we are the result of a miraculous chance, of an absurd cosmic rarity, or we accept there is something wrong with the rules. What if gravity changes? What if, in the depths of silence, where matter is scarce and accelerations are tiny, gravity relaxes? There is a theory called modified Newtonian dynamics, or MOND. It is a radical idea. It suggests gravity is not an immutable universal constant. It suggests that when attraction gets very, very weak, at the edges of galaxies, or in the vast deserts between them, gravity becomes, strangely, stronger than Einstein predicted. Imagine gravity like a rubber band. Near Earth, near the Sun, the rubber band is firm, predictable, but out there, in the void, perhaps the rubber band changes elasticity. If we apply this modified gravity to universe simulations, something magical happens. Voids like the KBC cease to be impossible. They become inevitable. In this new theoretical universe, modified gravity helps clear voids faster. It pushes matter to the edges more efficiently. It carves deeper, vaster abysses faster. The impossible becomes natural, and this brings a different kind of philosophical comfort. If gravity changes, then we are not a statistical anomaly. We are not a rounding error in the calculation of creation. We are the natural result of how the universe breathes. We are expected. Perhaps your mind works like this too. Maybe, in moments of high pressure, of noise, of work, you follow a set of rules, productivity rules, logic rules, Einstein's rules. But in moments of silence, in insomnia, in the void of the early hours, the rules change. The gravity of emotion works differently. Small thoughts gain huge weights. Distant memories exert a fatal attraction. You are not broken for feeling this. You are just in a low acceleration regime. You are operating under a different emotional physics. MOND tells us we don't need ghostly dark matter to explain why galaxies spin so fast. It says the law itself is flexible. But of course, the universe doesn't give up its answers easily. Modified gravity solves the void problem, but creates others. It struggles to explain the glow of the Big Bang with the same mathematical precision as the standard theory. It is a tug of war. On one side, dark matter and Einstein's gravity. On the other, modified gravity and the rebellion of the voids. And we are in the middle, floating on the battlefield. We are the evidence. Our existence, here inside this impossible hole, is the proof physicists are trying to decipher. We are the anomaly that needs explaining. This gives your life and your night a cosmic weight. You are not just a passive observer. The simple fact that you are here, looking at the stars from inside this desert, is a crucial datum. You are the witness to the mystery. And while scientists debate whether it is gravity that changes or matter that is invisible, the void continues. Indifferent to our equations, it keeps expanding, keeps pushing galaxies, keeps cooling light. There is a brutal honesty in the void. It strips reality of its adornments. In clusters, there is too much distraction. Hot gas, X-rays, crossed magnetic fields. It is hard to see the skeleton of the universe under so much flesh. But here it is just bone. Here we see the naked structure. We see the geometry of space-time stretched to its limit. If you want to understand the foundation of a building, you don't look at the decorated penthouse, you go down to the dark basement. We are in the basement of the universe, and it is here, in the dark, that fundamental truths hide. Perhaps the answer to the Hubble tension to the age of the universe, to the nature of gravity, won't come from big telescopes pointed at bright clusters. Maybe it will come from looking at nothing, from measuring silence more precisely, from accepting that the void is not a flaw, but the main feature. Think of the space inside your own atoms. If the nucleus of an atom were a marble in the center of a football stadium, the electrons would be dust in the stands. Everything else, the field, the seats, the air, is empty. You are made of void. Solid matter is an optical illusion created by force fields. In reality, you are 99.9999% empty space. You are a microcosm of the KBC void. This affinity, this resemblance between inside and outside, is what allows us to connect. When you look at the night and feel the vertigo of distance, it is not fear, it is recognition. It is the void in you greeting the void out there. We are made of the same absence, says the universe, and of the same light trying to cross it. This connection dissolves the barrier. You are not in the universe. You are the universe. You are the KBC void, becoming aware of itself for a brief moment before closing its eyes. And this awareness doesn't need to be heavy. It can be light as modified gravity at the edges of the galaxy. As light as the tired light that traveled 3 billion years from the Eridanus void just to touch your retina. Let physics handle the equations. Let Einstein and Mond fight over the rules. For you now, only experience exists. The experience of floating. The experience of being a conscious dust particle, sailing on a raft of stars, fleeing the center of a colossal nothingness toward a horizon expanding forever. It is a journey without a destination. And because of that, there is no way to get lost. You are already home. Home is movement. Home is vastness. Feel the bed under your back. It is also made of void and electric forces. It is holding you against Earth's gravity. But Earth is falling toward the sun, and the sun is orbiting the galaxy, and the galaxy is fleeing the void. It is an infinite and gentle fall, a cradle in perpetual motion. No need to hold on to anything. Your hands can open. Your thoughts can let go. They will orbit you for a while like satellites and then decay, burn up in the atmosphere of sleep. Let them go. The void is big enough to receive everything you release. It has 2 billion light years of space to hold your worries, and it won't even notice the weight. Give it to the void and float. What comes next at the frontiers of time is even quieter. What fills the silence when matter goes away? That is the question the void forces us to ask. We tend to think of space as an empty stage, where stars and galaxies are the actors. But the stage is not passive. The stage has a will of its own. Inside the KBC void, where the gravity of matter is too weak to hold things, another presence reveals itself. A presence that is everywhere, but can only be heard when the noise of galaxies ceases. Dark energy. Scientists say cosmic voids are the best places in the universe to study this mysterious force. Because voids are the only regions where dark energy dominates completely. In star cities, in dense clusters, gravity is strong. It pulls, it holds, it resists expansion. There, gravity is still queen. But here in the desert, gravity is just a distant memory. Without gravitational force to counterbalance it, dark energy takes control. It pushes space. It creates more space. It is a silent, constant pressure, coming from nowhere specific, but arising from everywhere at once. Imagine the air around you began softly to multiply, creating more air between you and the walls. The walls would move away, not because they moved, but because the space between you and them grew. That is what dark energy does in the void. It makes the void grow faster than anything else in the universe. It turns this hole into a bubble that swells, pushing filaments, walls, neighbors further and further away. It is a type of active loneliness. A loneliness that works hard to keep itself alone. And there is a geometry in this loneliness. If dark energy is uniform as we think it is, then it pushes equally in all directions. This means voids should be perfect spheres, round bubbles of nothing, growing in cosmic foam. When we look at the sky and map these abysses, that is what we look for, the perfect shape, the sphere. If we find distortions, if the void is oval or dented, that would tell us something else is happening. That maybe dark energy isn't constant, that maybe it changes with time. The void is a laboratory. a test tube 2 billion light-years long where we test the nature of nothingness. And what does this test tell us about the future? It tells us a story of increasing isolation. Dark energy won't stop, it is relentless, and as time passes, it will accelerate. Voids will grow. They will erode the filaments surrounding them. Walls of galaxies will get thinner, more stretched, until they break. The destiny of the universe is to become increasingly hollow. Imagine the distant future. Billions of years from now, voids will have consumed almost everything. They will have merged, forming even larger supervoids. Remaining galaxies will be isolated on small islands, separated by oceans of darkness so vast that light will never cross them. Today, we still see neighbors. We still see Andromeda. We still see the Virgo cluster. We still see the walls of our KBC void shining in the distance. But dark energy is pushing all of this beyond the horizon. There will be a day when a civilization, born on a lonely planet in the middle of this void, will look up and see nothing but darkness. They won't know there was a Big Bang. The light of creation will have stretched until it disappeared. They won't know there are other galaxies. The light of neighbors will have moved away faster than it can reach them. They will think the universe is just their own island, still eternal, surrounded by an infinite motionless blackness. We are privileged. We live in the era of light. We live in the moment when the structure is still visible. We know we are in a void, and not at the end of everything, only because we can still see the edges. Your anxiety, your sense of smallness, is the price we pay for this view. It is better to know we are small in a vast universe than to think we are big in an empty universe. And this dark energy, this force pushing everything away, and is it also in you? Sometimes we feel this internal pressure, an urge to push the world away, to create space, to push the walls of our life further so we can breathe. This is not selfishness, it is expansion. Maybe at times you need to be like the void. You need to let the gravity of obligations, the gravity of expectations, lose strength, and let your internal dark energy take over. Expand the silence. Create a safe distance between your core and the noise outside. The universe does this to survive, to keep growing. You can too. Dark energy doesn't destroy the universe. It opens it. It creates the stage for the future, even if that future is lonely. And the galaxies left behind, the ones that can't keep up with expansion, they become time capsules. The study of voids shows us that galaxies living here are, chemically, more primitive. Since they don't interact, don't collide, they don't recycle their materials so frantically. They keep original elements, pure hydrogen. They are samples of the young universe, preserved in the ice of isolation. You also have parts of you that are like this, parts untouched by the chaos of everyday life, old memories, pure dreams you never fulfilled but never forgot. These are your void galaxies. They are smaller, fainter, but they are original. They hold your essence, protected by the distance you placed between them and the world. Don't be afraid to visit these lonely parts of your mind. They aren't sad, they are preserved. They shine with a blue, young light, waiting for the right moment to form a new star. While you float, feel this duality, the gravity that wants to pull you to the ground, to earth, to dense reality, and the dark energy, the breath of the night, wanting to expand you, dissolve you, take you to the dream. Right now, on the threshold of sleep, dark energy is winning. The room's walls seem more distant. Sounds from the street seem to come from another galaxy. The body's weight decreases. You are becoming a void, and this is good. Let expansion happen. Let thoughts move away, carried by the invisible current. Don't chase them. They are going to the edges. Let them go. Stay in the center. Stay at the point where gravity is zero, where the only force is the gentle breath of space, opening the way for rest. The KBC void has 2 billion light-years of calm to offer you. It is enough space. It is enough time. No need to fill every corner. The universe doesn't fill up. It lets emptiness exist. It honors blank space. Be like the cosmos. Honor your blank space. Honor the silence between your heartbeats. And as we prepare for the final part of our journey, to look beyond the bubble, to where light has not yet been distorted, remember that you are the observer. Without you, the void would be just distance. With you, it is a landscape. If this landscape brings you peace, if this way of seeing the night makes sense to you, subscribe. Leave your like. Help this channel continue transmitting signals through the vastness. Now, let's look at the horizon, at the bubble's limit, where illusion ends and truth begins. But what happens when we look at the edge? If we are indeed inside this Hubble bubble, this cosmic aquarium, where does it end? Imagine you could travel, leave the Milky Way, cross the local group, pass Laniakea and continue. Travel for 2 billion light-years through silence. Eventually you would find the wall, the frontier of the KBC void. It is not a solid wall. It is a transition. It is like leaving a sparse forest and suddenly entering a dense jungle. Out there in the filaments surrounding us, matter density returns to normal. Gravity recovers its full strength. The expansion rate slows to the cosmic average. Out there, the universe is different, and we are trapped in here, trapped by distance, trapped by time. This frontier, this limit of our bubble, is our personal event horizon. And as dark energy continues its work, this horizon will change. Let's project the mind into the future, not tomorrow or next year, but deep time. Geological time, cosmic time, 4 billion years from now, our night sky will change dramatically. Our neighbor, the great galaxy Andromeda, which today is just a faint smudge of distant light, will grow. It is falling towards us, or we are falling towards it. In the void, the dance is mutual. It will get bigger and bigger until it fills the entire field of view, and then collision. But it won't be a car crash. It will be a merger of ghosts. Stars are so far apart they won't hit. They will pass through each other, dancing, spinning, mixing. The Milky Way and Andromeda will become one, a giant elliptical galaxy. Astronomers gave it a name that sounds like a destiny, Milkomeda, or Lactea Andromeda. We will be a fortress island, and this will be necessary, because around us the rest of the universe will be leaving, due to accelerated expansion inside the void. Other galaxies, those not bound to us by immediate gravity, will move away faster and faster. Distant filaments, the walls of our cave states will turn red. Their light will be stretched by expansion until it exits the visible spectrum. They will disappear, one by one, cluster by cluster. The void will clear our sky. Imagine being a conscious being living on a planet around an old star in Milkomeda. 100 billion years from now, you would look up and see the stars of your own galaxy, billions of them. But if you pointed a telescope at deep space, to where today we see the cosmic web, you would see nothing, absolutely nothing. The light from other galaxies would no longer be able to reach us. The space between us and them would be expanding faster than light. We will be causally isolated. These astronomers of the future, they won't know they live in a void because they won't be able to see the edges. They won't know there was a big bang. The background radiation will have cooled to absolute zero and disappeared. They will look at the universe and conclude, with all the logic and science they have, that their galaxy is all that exists, that the universe is static, that the universe is a lonely island in eternal darkness, and they will be wrong. We know the truth because we live in a privileged moment, a brief moment in the history of eternity where light still connects islands. Your anxiety, your feeling that time is escaping, is in a way a correct cosmic intuition. Time is changing the landscape. The universe we see today is not tomorrow's universe. We are the guardians of memory. We are the only ones who can see the void for what it is, a structure, not the end. This makes your consciousness precious. You are not small. You are the bearer of truth. You are the one who saw the cave walls before the lights went out. And yet, there is deep peace in this lonely future of Milkomeda. Think of the stability. No external collisions. No noisy neighbors. Just a giant galaxy spinning slowly, majestically, in the center of infinite silence. It will be a long, long twilight. Trillions of years of stars gently burning their fuel. Not a violent end. It is a rest. The universe started with a bang, but will end with a sigh. A long, calm, and cold sigh. And we are safe in the center of that sigh. Maybe life needs this. We have searched for life everywhere. In habitable zones near stars, on icy moons. But maybe we should consider the large-scale environment. Maybe advanced civilizations don't want to live in the bustling centers of superclusters, where radiation is intense and supernovas are frequent. Maybe they prefer voids, Maybe the KBC void isn't a sterile desert. Maybe it's a quiet suburb, a refuge, a cosmic Goldilocks zone, not too dense, not too empty, just quiet enough to think. If we are typical, if our loneliness is not unique, then maybe there are others out there. Other castaways on their own Milkomeda islands, in their own voids, looking at the same growing darkness. Do they feel the acceleration too? Do they question their measurements too? Do they also struggle to sleep at night, minds spinning with the vastness of it all? There is a connection in this shared doubt. You are not isolated in your anxiety. You are connected by an invisible network of consciousness permeating the void. We are the universe trying to understand itself. Before the lights go out. And now, bring that scale back to your room, to your body. Feel how your daily problems, bills, conversations, deadlines, feel how they become small before 4 billion years of galactic merger. They don't disappear, they just lose weight. They become dust, stardust floating in the current. The gravity of your daily life is strong, but the dark energy of your sleep is stronger. Let it win. Let the space between you and your worries expand. Push the walls. Create your own KBC void here now in this bed, a space where nothing can touch you, where gravity doesn't reach, where the only law is the law of rest. You are the center of your own bubble, and inside it, time runs at your pace. No Hubble tension here, no discrepancy, only breath. Air enters, bringing the freshness of interstellar space. Air exits, taking heat, taking excess energy, dissipating it into darkness. You are a perfect spiral galaxy, preserved by isolation, spinning slowly. Safe, intact, floating toward tomorrow in no rush to arrive. For tomorrow, billions of years from now, will still be there, waiting for you. The void is not the end. The void is the cradle. It is the space the universe created so you could exist and dream. Now, the journey is almost complete. Lights from distant filaments are fading. Mountains of matter are beyond the horizon. Only you remain, and the gentle vastness wrapping you like a velvet blanket. You understood the secret. The racing mind, the one that wouldn't shut up as it wasn't wrong, it was just trying to process infinity. It was trying to measure the universe with a human ruler. But now, you know, the ruler is made of silence. You are made of the same matter forming ancient stars. The iron in your blood, calcium in your bones, carbon in your breath, all forged in the hearts of suns already dead, long before this galaxy entered the void. You are ancient. You are vast. And you are exactly where you should be. There is no error in your location. There is no error in your existence. The hole in space, the 2 billion light-year KBC void, is not a manufacturing defect of the cosmos. It is the space needed for you to fit. It is the respite in the music of creation. And now it is your turn to pause. Feel the dark behind your eyelids. It is not empty. It is full of potential. It is the same dark filling the space between galaxies. It is a warm dark. Welcoming. Let gravity weigh. Feel yourself sink into the mattress, like a galaxy dipping into the fabric of space-time. Each muscle loosens. Each tension dissolves, carried by the accelerated expansion of relaxation. Thoughts still remaining are like distant comets, bright but harmless, passing far away on the periphery of your consciousness's solar system. Let them pass. No need to track them. No need to measure their speed. You are no longer the scientist. You are space. You are the silence sustaining the comets. The universe is much stranger than we imagined, and our place in it is more unusual than we ever suspected. We are cosmic castaways, adrift in a desert of space, measuring a universe that may not be what it seems. But for tonight, that doesn't matter. For tonight, the only truth is rest. The only truth is the peace of knowing that, even in the greatest loneliness, even in the greatest void, there is a structure, there is a flow. You are part of the flow. You are the memory of the universe, closing its eyes to rest. If this journey brought you calm, if the void offered you a refuge, know that it will be here tomorrow. The universe is in no hurry, and this channel will be here, transmitting into the darkness, waiting for your return. Thank you for traveling with us. Thank you for observing. Now, engines off, navigation lights out. Let the current carry you towards sleep. toward silence, toward the dream.